Hello, today I'm going to be writing some UE code. It is a language I've been working on. I'm not going to give a whole intro for everything that's going on, but I'll tell you a little bit about it. It's based based on lambda calculus. It's not quite a lambda calculus for I think a couple of kind of one major distinction, which I'm not going to get into, or at least one minor kind of thing. Anyways, that's neither here nor there. What I'm working on today is a program in this language to dynamically link dependencies required by other programs. This is an interpreted language, and so typically what I do when I have a dependency is I just read a file, parse it, and evaluate it. Um, but I want a way to dynamically link those so that I can cache dependencies. So if multiple files in the same program require the same dependency, I won't have to you know, read and parse and evaluate the same kind of file multiple times. So I'm writing a program called agency to help me do that. The language is called UE, by the way, if you didn't know that. And so agency writes like an idle agency. So you get to orchestrate your units. It's fun, cheeky. But anyways, I have some kind of working code here that will go through a kind of, I call it a package. It's not quite a package, but it'll go through a package kind of manifest, which is the declaration of the package that contains its dependencies and also defines executables and libraries in that package. And so right now what I have is this code works for executables, kind of. There's some kind of tweaks I have to make to it. I also am not entirely sure how I'm going to implement this, so there's going to be probably a pretty good amount of debugging and stuff like that that happen in this as I'd figure out how exactly I want this to look and work, because I haven't really quite nailed that down yet. So anyways, I'll make a template kind of project so that we can kind of see what this is going to look like. So the thing about agency is that it's implemented in UE and it's for UE, and so it's really not it's not like a language specific package manager or linker. It's really just more of a standard. So you write programs according to the agency standard, and then agency can run it. So, excuse me. I have a snippet here. I'm just going to do that, probably. So, not that. Hold on. Agency manifest. Here we go. Okay. Example. Okay, so the key parts of an agency manifest are, first of all, the declaration that it's agency. Actually, I should clarify first of all, is that UE has a lot of records in it, which I think if you're I guess familiar with Haskell, it's a record, but if it might just look like JSON, it's kind of the same thing. They're immutable though. That's a pretty important distinction. So every UE file is an expression, and so an agency template is just an expression containing a record in it. And so an important part is the declaration, which is the type of this. So any variable prepended by this single quote becomes a free variable. They're always free, so I use these as data constructors. So UE is dynamically typed, but it's strongly typed, but kind of mostly untyped, really. The strong typing just comes in some prelude functions for integers and floats and strings and stuff like that. But I use these free variables as data constructors, and so there's no data declarations. So yeah, you can figure out how that works. Anyways, we declare the type, which this is an agency package. So there's that, and then here's some agency metadata. It's not very fancy right now, so I don't even have a version number for agency, but I'm gonna assume that at some point in the future there might be a feature set that later versions of agency support that Earlier ones don't, of course. This is the version of the package in case you want to do some version control. The name of the package. There's an initialization function included, which is optional, right, as noted here, which you can use. So the product of this init function is an IO record, and then that record is then passed to this component function. So you can, have like runtime setup of different packages and stuff. That's probably not a great idea to include, but until that turns out to be problematic, I'm going to keep that as part of the design. And then within this component, there are right now two different components, but kind of three. So there's executables and libraries, and then there's public and private libraries. So the idea is that any sort of component or subcomponent, I guess you could call these, inside of a package could depend on the package itself. And so anything that depends on this own package has access to the private library. And then any other package that depends on a different package can't access those private libraries, but of course it could access the public ones. So that's the idea behind that. But anyways, this actual file doesn't do anything by itself, but it's just a declaration of the programs contained and what they depend on. So all of the paths in here should be relative to the manifest or the package definition. So if we want to say here, we'll make our executable file here. Here. And then there's nothing in there right now, but I think what I want to do is we will have a depends as a record, and then there are different types of dependencies. So I'll show you the one that I have right now, which is just a pure dependency. So let's call this library this dependency. We'll just call this dependency lib_a. So, or actually dep_a. How does that sound? So the dependencies are qualified by this name. And so this is the name by which this function will reference the dependency here. So I'll say here pure source pure lib_a.ue. And I'll get into what the pure constructor is supposed to do in a second once I add this source pure lib_a.ue. So a pure dependency is supposed to be a path that points to a file that just returns a pure record. There's a different dependency for IO records, although I may end up not supporting those, but pure records are the most common use case. So like we'll open Prelude here, so I have access to Prelude functions, and then I'll just say that like some value is equal to that. Or actually, I'll just say some value is equal to the constructor some value. How's that sound? Lib_a. And then now, since I've declared this dependency, I should be able to go into main.ue and then like first of all we'll open Prelude again. I'll open a do expression so that I can do IO, and then put string.line, and then label is how constructors are called in the Prelude, label.show, and then dep_a we can reference that foo, and then not foo, some value. And then the idea is that we can invoke agency and tell it to run this executable in this package, and then this should run with like the correctly linked values inside of it. So we can try doing that. I was testing this a little bit yesterday and got it to work. It might take me a minute because some of the pathing stuff is like not quite correct yet, but what is this? Agency.run path scratch slash example.ue, and then we want to run, what was it, example exe. And then we can try running this and hopefully it'll work. Could not resolve. Pure in the environment. Okay, hold on. Env type agency init component run. Where is this getting called by? Oh. No, that's not it. Anyways, hold on. Let me try that. I think that I don't need that. That's one of the things I've not implemented yet, so, or not quite correctly implemented. There we go. So yeah, I can run that, and then now it prints out this sum value. So there you go. That's the idea in a nutshell right there. So anyways, there's a couple of problems for me to iron out, so I'm just going to get started on it. I'm going to do my best to not like monologue about the language and stuff as I go, but rather to just kind of work on this. So this may not be a super entertaining video, but if you want to, I don't know, like hear somebody yapping in the background, you can put it on, I guess. So anyways. I'm trying to remember exactly what I needed to do here. So this eval here is responsible for collecting all of the components. So this, here we go. I'm thinking out loud. Okay, I have to make this a little bit more readable for myself here. Okay. Resolve depths, okay. This value here corresponds to this block here, or rather this block here. And so we then, this guy gets traversed in these guys. The subcomponent is this thing, this record. So let me highlight just the inside of that record. And so one of the first things that I need to do is I traverse over this record and then get the dependency, get this set of dependencies and then resolve all of those. But I'm missing an additional step where I actually run this program with those dependencies, because right now that running part is deferred until up in here. But if I want to actually depend on other agency packages, I have to actually have that as part of the package definition. And so running all of the dependencies is not a problem, because UE is completely lazy, and I'm making sure to thunk everything. So what I'm doing is creating instructions to run the executable, but I'm not actually running anything yet until it's forced by the runtime to evaluate. So I can just lazily create all those thunks and then have them all shake out elsewhere. So that's kind of what's going on here. There's like kind of two layers of thunks, because I'm manually creating thunks with mvars, and then UE itself is also lazily evaluated, so the values themselves also are thunks too. So anyways, had to have some coffee. So let's see. Subcomp here. Just trying to remember. I wrote all these out so that I could kind of figure out what I was doing, but now it's a little bit more confusing than it should be. resolved depths. This is the exec subcomps. This is just a callback to, or that's just an alias for that function. For traverse executables. Okay, hold on. I'm going to rewrite this so I can understand this a little bit better, because I wrote this last night. I probably was not quite in my right mind while I was doing it. So we'll define a record so that we can kind of space everything out, I suppose. And then, so it's nice and readable. And then after we define the record, we can immediately call a field of it to get a value out of it. So let's see. This path, this is a directory. The component is this whole thing right here. And so what we want to do is let's just write a new function. Define package. I think what I'll call this is link executable. Of course, I'll have to also implement very similar functions for the libraries, but those are a secondary concern at this point. That should be really similar to the executable case. You just don't execute it, of course, because there's nothing to execute. It's a library. This path, let's see, here's the executable. So this is the subcomp. This def is a recursive, it's a recursive reference to the package being defined here. It's being passed in via this fix.io function. Excuse me. So if a package self-references itself, the idea is that it uses this def, and that corresponds to this exact thing. So as long as you don't have like any cycles appearing in your dependency graph, this should be totally fine. So like you could have cyclic kind of module dependencies, but as long as the values themselves aren't cyclic inside the modules, then it should be okay. At least that's what I'm aiming for. So if that turns out not to work, I'm gonna be really disappointed. But I've gotten like a much simpler POC of this working before, so I think it should be probably okay. So anyways, let's try to organize our thoughts here. So every executable, right, for now just defines a path and dependencies. So we want to resolve all the dependencies by thunking their evaluation. Then we have to traverse that dependency set, and then force those thunks so that they become pure thunks. And then we pass that dependency set to this file, and then we want to actually execute this file and then just return that thing, the product of that execution in the space of this block. So we're basically just updating this record to replace this block with an IO computation. Basically, that's kind of the idea. So let's see, we can resolve dep should mostly just work for now, at least for pure paths. So let's do record.traverse exe subcomp.depends. And then for this guy, what we want to do is resolve dep our cache, our path, and then this definition. And I think, let me flip this around, because this is going to be probably used inside of a traversal too, I bet. So okay, so there's our resolve dependencies, and then we want to, let me think, resolve dependencies. We want to map over this. it's important that we map over this and not traverse. Well, first of all, we're mapping to pure values, so I guess it doesn't really matter. But we want these values to be lazy and not like to sequence actually resolving all of them in order. Right? Because obviously we want this to be kind of pole-based linking, not push-based, because you can do a lot of static analysis up front and figure out all of your like graphs and your topological order, then which you should resolve dependencies and stuff. And I didn't want to do that. So if you do everything lazily, it kind of just shakes out on its own. At least hopefully that's the idea. So we want to compose, unsafe perform IO, and thunk.force. And then that should turn this into a record of these dependency names and the record returned by this dependency. And then let's see. Now we want to execute this path. So we'll say that our actually, hold on. Let me I have to remember this is not a do block, this is a record. So, because this returns an IO action, so this is IO, right? IO, some record. This takes some record and returns a different record. That's about as much as I'm going to annotate those types for now. Let's actually just write this out. This would probably be easier to just do this in a do block. Let me just copy this. I'm going to get rid of this record. I don't think that I actually need this. Okay. With is kind of like let binding, but it lets you define a whole record. So that's how we define pure values in here. Inside of a do block is with a with keyword. So, in case you wanted to know. Force resolved depths like that. There's our thunk depths. So let's see. One of the things actually that would be nice to be able to do is that as part of resolution, we turn this path into an absolute path. I can do that again here. It would be nice to not have to repeat that work. Actually, no, what am I thinking of? No, you turn these paths into absolute path. You haven't even touched this one yet, so okay, I can do that. That's no problem. Bruh, I don't even know what I'm talking about. We will open our IO path record. Don't worry about that. Make absolute. And then we want to make our path relative to this path, which is e subcomp dot path, like that. There's our path. So then now we should have something that looks pretty similar to the value here. So there's our map. We have to still insert the prelude into it so that our executable has access to that. But then here's our executable. So then the only thing left to do is to open the file, read it, parse it, and then pass this data into the interpreter so we can evaluate all of that. I think that's probably about right. So define package, link executable. Okay. let me think. Actually, as part of this executable, probably what we want to do is, oh gosh. We want to return a thunk because we're going to evaluate the executable, but we want to thunk that. So let me think about that. I think actually what I might want to do is thunk this entire thing, probably. So then all the dependencies are only evaluated if the executable is called. I think that is correct. I think that's what I want to do. So path, resolve, dependencies, path. Okay, I think that's right. I don't know, probably. Anyways. I think the last step is evaluation. Agency, run, eval, yeah. Okay. To expose the prelude to that. Okay, so this is link executable. I don't really know if that's really the appropriate name for that. Let's just call it thunk executable. How does that sound? Okay. And let me think. Defining a package turns a package declaration into the definition, which has all of the executable code in it. That is defined inside of a fix.io, so it should be a monadic function. But how does this thunking work? Maybe it should be pure. I'm kind of thinking it should be a pure function. Because everything is going to be thunked. Because I want this basically to have a structure like right, like this should end up something like this, and then you can call dot executable dot example exe, and then that turns into an IO value. So and really, like, I think it makes sense to have that be a pure value because, like, the whole point of this linker is to be like non-sequential, right? We want it to pull dependencies as required rather than having to sequence and traverse all of our dependencies at once. So well, it'll be IO, I guess. because creating the thunk is an IO operation. So we'll traverse all of the subcomponents in here, and that will sequence the thunk creation. I just have to remember that when the package is called, when you call a subcomponent, you have to force the thunk in that subcomponent. So let's do this. We will excuse me. This component is this block. So let's do this. Executables equals record traverse something comp dot executable. And we traverse. This only traversing doesn't traverse over the key, it traverses over the value, so the name is unaffected by this. So the traversal function is not a prelude function. I defined it inside of here. Just by the way. Let's see, where am I? So I think we can just traverse thunk executable, probably. I'll get to libraries later. It'll be, the libraries have the exact same structure as executable, so there's no difference in doing those, but I just want to try to keep it as minimal as possible so I can test when stuff goes wrong. There's our executables. We want to return on the executables. I think we could probably just return the actual object, or the actual record that has thunks in it, rather than forcing all of the thunks probably. So pure executable equals executables, like that. And I don't know, let's try that and see what happens. So I'm gonna clean that up a little bit. So now I can get rid of this part. exe, here's the code component. Exe code, I think I can get rid of all this. So hopefully if everything goes right, I should be able to just do thunk.force code component dot executable, and then we want to dynamically retrieve this executable from this record, so there's a prelude function for that. So record.get exe name from the executable record. So I don't know, maybe it'll work. Let's find out. It probably won't, but you never know. Could be pleasantly surprised. So let's try that. Let's do agency.run scratch/test example, rather. Okay, yeah. It worked! Oh my gosh, that's so exciting. I'm actually really pleased that that worked. Okay. Now let's increase the complexity of our test case here real quick by adding another dependency just to make sure this works. Here, lib a pure lib b prelude if we go to main, let's go ahead and try that. It worked. Beautiful. There you go. I'm going to end it here because it's about 35 minutes long. So anyways, a little bit of refactoring. But this will be good. This is going to be something that I use when I write the support for the actual agency dependency type. Because right now just peer is supported, but the agency one will be really useful. So anyways, thanks for watching. If you watched, bye bye.